Hello everyone, I am Abhay Singh, and in this video I'll be discussing about naive-Bayes classification, its application, its advantages, its disadvantages, and its implementation using Python. So let's begin with introduction to naive-Bayes algorithm. So the naive-Bayes algorithm is made of two words, naive and Bayes, which can be described as naive. It is called naive because it assumes that the occurrence of a certain feature is independent of the occurrence of other features, such as if the fruit is identified on the basis of color, shape, and taste, then red spherical and sweet fruit is recognized as an apple. Hence, each feature individually contributes to the identification or identifying that it is an apple without depending on each other. Now, what is Bayes? It is called Bayes because it depends on the principle of Bayes theorem. And Bayes theorem can be defined as Bayes rules or Bayes law, which is used to determine the probability of a hypothesis with prior knowledge. It depends on the conditional probability. There are certain assumptions that each features make in Bayes theorem. Few of them are listed below, in which first we have is feature independence. So this assumption states that the feature of a data are conditionally independent of each other given the class label. Second we have is continuous feature are normally distributed. This assumption states that if a feature is continuous, then it is assumed to be normally distributed with each class. Third we have is discrete features have multinomial distribution. This assumption states that if a feature is discrete, then it is assumed to have a multinomial distribution with each class. Fourth assumption we have is features are equally important. So this assumption states that all features are assumed to be contributed equally to the prediction of the class label. Fifth and last one we have is no missing data. So this assumption states that the data should not contain any missing values. So these were all the assumptions regarding Naive-Bayes algorithm or the which the features make. Next we have is the theorem state or the formula of Naive-Bayes theorem. So this formula states that the probability of event A when probability of event B is given is equals to the probability of event B when the probability of event A is given into the prior probability of A by probability or prior probability of B. Next we have is the theorem states or the formula of Naive-Bayes theorem. This formula states that the probability of event A when the probability of event B is given is equals to the probability of event B when probability of A is given into prior probability of event A upon prior probability of event B. So this was formula related to Naive-Bayes classification. Now we have several applications of Naive-Bayes classification. First we have is text classification. So text classification includes spam filtering, sentiment analysis, document categorization. Second we have is medical diagnosis. And medical diagnosis includes disease prediction based on symptoms. Third application of Naive-Bayes application we have is recommendation systems, which includes product recommendations. Fourth application we have is real-time predictions, which includes weather forecasting and fraud detection. So these were several applications related to Naive-Bayes classification. Next we have is advantages of Naive-Bayes classification. So first advantage we have is Naive-Bayes is one of the fastest and easy machine algorithm to predict a class of datasets. Second advantage we have is it can be used for binary as well as multi-class classification. Third advantage we have is it performs well in multi-class prediction as compared to the other algorithms. Fourth advantage we have is it is the most popular choice for text classification problems. There are several disadvantages of Naive-Bayes classification as well, in which we have Naive-Bayes classification or Naive-Bayes theorem assumes that all the features are independent or unrelated. So it cannot learn the relationship between features. So these were all advantages and disadvantages related to naive-Bayes classification. Next we have is code for naive-Bayes classification. Here is the code and here is the output for the given code. And here is the explanation of previous code, in which first we import several libraries such as sklearn naive Bayes, which provides the Gaussian NB class for implementing naive Bayes algorithm. Second we have is sklearn model selection for splitting the data into training and testing sets. Third we have is sklearn metrics for evaluating the model performance. Then second step we have is preparation of data, in which we create a sample data X with features and Y and corresponding class labels. In this section, we split the data into training and testing sets using the train test split function, and then we create a and train the classifier. Next process we have is initiate a Gaussian NB object and then train the classifier on the training basis using the fit method. Here is the fit method that I mentioned. And the next step we have is make predictions. So in this, we use the train classifier to predict the class labels for testing data using the predict method. Here is the predict method. And last we have is evaluate the model. In this, we calculate the accuracy of the prediction using accuracy score. So this was all about naive Bayes classification. I hope you liked the video and thank you.